Ladies and gentlemen, welcome back to the ISITIA 2021. I hope you're warmed up again to continue to the last keynote speech from invited by IEEE ITS student branch. There will be Dr. Muhammad Rizky Utama Saputra from Jakarta Smart City, and this afternoon we will have Muhammad Abdul Hadi STMT from Department of Electrical Engineering ITS as the moderator. So, ladies and gentlemen, please welcome Dr. Muhammad Rizky Utama Saputra and Muhammad Abdul Hadi STMT. Time is yours.
Thank you, Mrs. Aulia. Good afternoon, ladies and gentlemen. I hope that you are always in a good healthy. Today we are going to start our keynote speaker session, and we already have our invited speaker here, Dr. Rizky. And before we start the sessions, let me introduce and read the biography of Dr. Muhammad Rizky Utama Saputra. Right now, he is affiliated to the Jakarta Smart City Department of Communications, Informatics, and Statistics of Provincial Government of DKI Jakarta since April 2021. And his position is senior data scientist. He is recently graduated from University of Oxford at 2021 for his PhD degree in computer science. And before that, he was in University Gajah Mada for master and bachelor degree. He has several working experience such as research associate and research assistant and the Cyber Physical System Group Department of Computer Science, University of Oxford. And then he was machine learning laboratory demonstrator. And also he was a founder and technical leader of Lexipal Indonesia that is running on the area of educational application for children with dyslexia. And also here, he is a young and talented person with several awards, and the latest one is the winner of Liputan 6 Awards for dyslexic children. He has many publications on high impact factor journals such as IEEE Robotics and Automation Later or RAL and ACM Computing Surveys. And also in several famous top conferences such as Triple AI Conference on Artificial Intelligence, ACM Conference on Embedded Network Sensor System, IEEE CVF International Conference on Computer Vision, ICCV, IEEE RSG International Conference on Intelligent Robotic System or IROS, IEEE International Conference on Robotics and Automation or ICRA. Well, in this talk, Dr. Rizky will share his experience about the application of artificial intelligence for smart cities. And then let's start our keynote session right now. Dr. Rizky, please start your presentation and the time is yours.
Thank you, Mr. Hardy. Yeah, let me share my screens first. I hope that you can hear my sound clearly.
Yes, Dr. Rizky, we can hear your voice clearly.
Right.
And also your screen is already appeared here.
Okay, thank you, Mr. Hadi. Now I will start my presentation. Good afternoon, everyone. My name is Muhammad Rizky Utama Saputra. I'm a senior data scientist from Jakarta Smart City. First of all, I'm honored to be here, and I would like to thank the ISITIA organizer for this invited talk. Today, my presentation is entitled Artificial Intelligence for Smart City Application. In today's talks, this is my agenda. So the first one, I'm going to discuss about the background and the motivation. Why do we need AI for smart city application? And the second one, I will introduce a bit about artificial intelligence and its current research trend in the area of smart city application. And the third one, I'm going to talk about AI for smart cities in Indonesia, particularly by using the case study in Jakarta Smart City. And the last one, I will discuss the challenge and the future work in case you want to do more research about AI in the context of smart city. Let's move to the first topic. Why do we need AI for smart city application? In this slide, I show you two figures that compare the population density in the United States and in Indonesia. As you can see on this figure, so this is a 3D map that shows us the population density for a particular area in either United States or Indonesia. So the highest the bar is, the higher the population density in particular area. For example, in New York here, the population density is much higher compared to, for example, the Chicago city here. And as you can see as well in this map on the right side, the population density in Indonesia is also concentrated in particular area. So as you can see here, the population density is concentrated in the Java Island. And when you compare it with another island outside the Java Island, then the population density is much more less significant compared to the population in Java Island. And now let's take a look into something more specific, which is the population density in particular cities in the world. So this figure produced by the World Economic Forum. For this one, it is produced in 2014, and this one is produced in 2013. So the figure on the left shows us the world's biggest cities. So this is just a projection for the year 2030. As you can see here, based on the World Economic Forum, the world's biggest cities in 2030 will be the Tokyo in Japan, in which that it is projected to have more than 37 million population in a single city. So this is even bigger than the number of population in Greater Jakarta or Jabodetabek area in Java. And then the second one is Delhi, India, with around 36 million population, followed by Shanghai, Mumbai, and then until Mexico City in Mexico. The good thing is there is no city in Jakarta, in Indonesia here, that is listed as the world's biggest cities in terms of the number of population. Then we can see here in the second figure. So this is the figure of that show us the world most crowded cities. So if the previous figure just show us the number of population, now in the second figure, we take into account also the size of the city. So the World Economic Forum compute the number of population or the number of people per square kilometer. So as you can see here, the first one that is considered as the most crowded city is Dhaka in Bangladesh, which has more than 44,000 people per square kilometer. So as you can see in this graph that Dhaka is not even in the list of the world biggest cities in 2030. But when we look at the per square kilometer, as you can see that Dhaka is considered as one of the most crowded city in the world. And then the second one is Mumbai in India, followed by many other cities around the world until we found in the number 10, which is Jakarta, Indonesia. So here, as you can see that Jakarta is considered to be one of the world most crowded cities in 2013. So it is important to note that this number is reflected the data in 2013. So the actual number of a year might be different than the one that is reported here. So what is the problem with this high population density? When a city has a high population density, it will be overcrowded. Then when the cities start to be overcrowded, it will create many different kind of city problems, from traffic congestion, flooding, poverty, inequality, environmental problem, air pollution, etc. So as you can see here, I put this figure, which is taken from Jakarta, which indicate that all of this problem that I mentioned is also exists in the capital city in Indonesia, which is Jakarta. Now I'm going to show you some fact about some of this problem that I mentioned before. So this is the fact about traffic congestion and pollution around the world. So the figure on the left shows us the traffic index collected by TomTom Traffic Index. And they list the city, the most congested city in the world. As you can see here, the first one is Moscow region, with the congestion level in 2022 about 54%. So what they mean by this congestion level, the 54%, is that, for example, when you take a trip of an hour, then in condition when the traffic is congested, you need more than 54% additional time in order to finish the trip. So if, for example, in the uncongested condition, you take an hour, then in congested condition, you will take 1.5 hours, for example. So this is just average number, but the number could be much higher or sometimes lower than the average number. So the TomTom index also lists the congestion level month by month. So as you can see here, if the bar is colored by the red color, it means that the congestion level is beyond 50%. If it's colored as orange color like this one, it means that congestion level is between 25% to 50%. And if it's below like around 15%, then we typically color it as a green color here. So surprisingly, in 2020, Jakarta is listed in the number 31 instead of like a Big 10 most congested city. So why is that happen? Because in 2020 we have a pandemic, we have a new normal era, and during that time the Jakarta government enforced large-scale social restriction for a couple of weeks or even for a couple of times, And at that time, that reduced significantly the traffic congestion in the city. So as you can see that the average congestion level month by month is reduced significantly after March here. But then again, we have another problem, which is air quality and pollution, as you can see on the figure on the right. So this is the data that is taken by AQAir. So this is the World Air Quality Ranking. The data I take in 13 June 2021. So as you can see on this graph, Riyadh in Saudi Arabia is considered as the worst air quality or the worst polluted city in the world. And then Jakarta is listed as the number 2 with the worst air quality. So we have like the US AQI. So this is like an index to measure the air quality. So if the air quality is beyond 100, it's considered to be unhealthy for the people to breathe, especially for the vulnerable people. But if the air quality is below 100, it considered healthy. So as you can see here, typically in the top 10, the air quality is like beyond 100. But then again, the data that is updated by the IQAir, the data is changed daily. So this one I take it in 13 June. So the actual data for today might be quite different than this one. But then again, I just want to mention that traffic congestion and air pollution could be one of thing to be think about when we design a solution for a smart city. And then this is another problem that quite common in a big city like Jakarta, which is a flooding event. As you can see on this map here, that this is the map that shows us an area that has a high risk of flooding in Jakarta. And the area is colored with a different color to show the different cause of this of the flooding. So for example, as you can see here, this tail color indicates that this area has a high risk of coastal flooding. So coastal flooding is a flooding event that happens because the rises or the increase of sea level. As you can see as well, there are many different kind of causes of flooding. So for example, in this dark blue color here, this area has a high risk of coastal, pluvial, and fluvial flooding. But I won't go into detail about this definition of pluvial and fluvial flooding here. And then in the next figure, I show you the land subsidence in Jakarta. So this is another concerning fact about Jakarta. So this data show us the projection of the land subsidence from 1997 until 2050. As you can see on this figure that in 2050, it is projected that more than half of Jakarta will be below the sea level. And that's even more alarming that in some area, the land high is even below more than 5 meters below the sea level. So this is again another kind of concerning event that we need to analyze and predict well, such that we could create a better smart city solution. So now, where is the part of smart city in order to help all of solving all of this problem? So by definition, smart city use information and communication technology in order to improve the government efficiency, especially in order to help them to create a better regulation or better policy, policy to solve all of this kind of problem. So in particular, by using smart city, the government can share information with the public, and then they can also provide a better quality of government services and citizen welfare. So the main goal of smart city is to optimize the city function and promote economic growth, while at the same time improving the quality of life for the citizen by using smart technologies and data analysis. So the keyword that I would like to underline here is the usage of smart technologies and data analysis. So this is the part that AI, artificial intelligence, can be used to improve the quality of service in the government. And then as you can see on this figure that smart city application or AI or smart technologies application can be implemented in different kind of domains like public safety and then smart health, water quality, smart environment, waste management, etc. And then in this slide, I'm going to show you the study conducted by McKinsey that lists the three most important layers of smart city application. So the first layer is the technology layer. So in this layer, it will has the network of connected devices, sensors, IoT devices, and other embedded or mobile devices that can be used to collect data throughout the city. And then in the second layer, we have smart application and data analysis. So by collecting all of those big data from all of those devices, we can use this data to create intelligent application and data analysis in order to help solve the city problem or even make a better policy to solve all of this problem. So this is where most AI application reside in this second layer. And then the last layer is the adoption and the usage layer. So this is the layer in which that we will adopt and use smart city application for particular usage, such that it will eventually improve the decision making and change the behavior of the people inside the city. And then at the end of the day, when we're creating a smart solution in smart city, we want to improve multiple aspects of the quality of the life in the cities. And that include the time dimension, health dimension, environment, connectedness, jobs, and cost of living. So for example, in time dimension, the government could create intelligent traffic management in order to analyze which area in the city that has a lot of traffic congestion. And then they could also predict this degree of traffic congestion in particular area, such that all of those analysis, all of those prediction can be used to create a better policy about, for example, about road construction and other policy that could finally reduce the impact of traffic congestion in a city. Another example is in the health domain, especially it is quite important in this pandemic era, in this new normal era, which is the development of data-driven public health intervention. So for example, by using like data science or artificial intelligence analytic, they could create like a forecasting of, for example, COVID-19 cases in particular area in the city. And then they could help them to, for example, create regulation about a large-scale social restriction or a lockdown or something like that. So all of those kind of activities which involve a data-driven method or artificial intelligence will eventually help the government to create a better policy for the city. So that is the background and motivation why we need AI for a smart city and smart solution in the city. Now we are going to go into the second topic in my talk, which is the introduction of AI and its current research trend in the area of smart cities. Before we go into the definition or the conceptual, the fundamental concept of artificial intelligence, I'm going to show you a bit about these Google Trends on big data, artificial intelligence, and smart cities. As you can see on the figure on the left, this figure shows us the popularity of big data and artificial intelligence from 2004 to 2018. The blue line here shows us the trend for big data. And then the orange line here shows us the popularity trend for artificial intelligence. As you can see here in the beginning of 2004, the trend for this, the keyword trend, this is the searching keyword in Google, is quite high, but and then it decreased significantly until around maybe 2010, and then increased again in 2014 and 2015. But then again, it is important to know that the increase of popularity in artificial intelligence is so up after the increase of popularity of big data. So why this is important? Because typically when we design or when we train an artificial intelligence model or agent, we need huge amount of data. So this huge amount of data will be provided by a big data solution. So that's why, so AI, artificial intelligence, machine learning, and deep learning, they start to gain huge popularity after big data as a, large increase of popularity as well in around 2012. And then this is another figure that shows us the popularity of smart city keywords from 2004 to 2018. So as you can see as well here that around 2014 and 2015, the keyword for smart city also increased dramatically, although it kind of flattening a bit afterwards. But this is, I just want to show you that all of these keywords, big data, AI, artificial intelligence, and smart city, it will be a quite interesting research direction if you're interested with all of these keywords, because it's gaining much more popularity recently. Then I'm going to show you a brief history of artificial intelligence in this graph. As you can see here, I show you kind of two different timelines about the history of artificial intelligence, because typically people tend to have different opinion about what is important and what is not important in history. So for example, here in this timeline, they mentioned that one of the first moment when AI is gaining popularity is when Alan Turing here, which is, you might know it as a British scientist that invent the Turing test. So at that time, they created a Turing test to test whether a machine is as intelligent as human. And after that, like around 5 years later, artificial intelligence is coined as a term during a conference in this topic. So some group of people think that this is kind of one of the beginning of when AI become blossoming. But and then you know that in history of artificial intelligence, there are ups and downs. So sometimes when people think that there is a huge potential in artificial intelligence, there are many funding and then there are many research on this area. But especially in around like 70 and then 80s, at that time, there are not enough data and there are not enough good hardware to support the development of artificial intelligence. So because of that, there are many moments in history that artificial intelligence lose its popularity because people think that it can't work as they expected. Because at that time we have no large amount of data and we don't have a GPU hardware that could be able to train a big neural network. But then again, after a couple of years, nevertheless, there are some group of people that still keep pushing this area. Like for example, Geoffrey Hinton, if you know it, and Jan LeCun as well, and Joshua Bengio. So those three are the founding father of artificial intelligence. They invent like back propagation, convolutional network, and something like that. So the one that I emphasize here. Although it's still debatable whether they are truly the one that the first coined the term or invent the approach, but they are the one that make it actually works and make it famous. So people think that those three guys are the one that should be recognized for the blossoming of artificial intelligence. And then I want to show you as well this graph here on the right side that show us why then again in this around 2010 or 2012, the artificial intelligence or deep learning or machine learning start to gaining large popularity. So there is a competition, there is a competition in computer vision area, which is called ImageNet. So ImageNet is a large-scale image classification competition that is held by academic in US, particularly led by Fei Li, which is a professor in Stanford University in United States. So this competition was held every year, and then many researchers and many research group in the world, they submit the best algorithm for this competition, and then they will announce the winner of the competition. So as you can see here in 2010 and 2011, the winner of the competition are an approach that is based on feature engineering, which means that given an image, you typically need to extract the feature of this image and then classify the image based on these features. But then start from 2012, suddenly there is a one method which is based on convolutional neural network suddenly beat all of those previous approaches by large margin. So as you can see here, the error kind of reduced from 20% to 16% in just a single year. And after that, then everybody in the world think that convolutional neural network is very promising, and then they start to use this to many kind of problem, including solving ImageNet. So as you can see here, at around 2014 or 2015, the accuracy is reduced significantly, and people think that ImageNet has been solved. And we also know that at the moment, classification algorithm has been used in many different kind of domains, including the one that we use as well in Jakarta Smart City. Right. So another thing that you might hear about artificial intelligence is maybe the first one is about Turing test. So this is the thing that I mentioned before about a way to test whether a machine is truly intelligent or not. So typically in the condition, we have human questionnaire here that try to ask a question to the computer respondent. And then if the human questionnaire cannot differentiate between the response from the computer respondent or the human respondent, then we could say that this machine passed the Turing test. So this is, I believe, one of the things that you might think about when you first hear about artificial intelligence. And another thing or another term that you often hear in the community or in the news about artificial intelligence is, I believe, is deep learning. So deep learning is one of the most famous breakthrough in the area of artificial intelligence. And as you can see here in this graph, that deep learning is actually just a subset of artificial intelligence. So deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. But artificial intelligence is not only about learning, it's not only about machine learning, it's not only about deep learning. Artificial intelligence might cover another things like, for example, search. So what I mean here by search is an artificial intelligent agent or model. They should be able to effectively and efficiently search the optimal solution from a huge space of problem. So artificial intelligence should also cover logic and knowledge representation. So what I mean here is that in AI agent or AI models, they should be able to represent the knowledge logically such that they could understand by the digital computer. And AI agent, they can also have a planning mechanism. So they should be able to plan the task in the future based on the data that they have at the moment or based on the historical data that they have in the past. And then when we look at the potential application, it is quite diverse. We can use artificial intelligence in the area of natural language processing, in the vision, robotics, and then graph analytics, simulation modeling, audio analytics, and image analytics, etc. And we're going to discuss some of them later in my presentation. Now, how do you train an AI agent or AI model? So typically, when we try to train an AI model or AI agent, we divide it into two stages, the training stages and the testing stages. So in the training stages, what we want to achieve is we want to train our model such that they could produce sufficiently accurate prediction. So for example, in the case of image classification, typically we have a single images or a patch of images as the input. So in this example, you can see that this is the picture of me. And then I give this picture to the this simplified AI model. So which is consists of, for example, here a convolutional network and a fully connected layer. And then this model will produce an output, a prediction. So in the case of image classification, the network will classify the category of this image. What is this image about? And then typically, the output prediction is not only just a single output, but instead it is a probability distribution. So as you can see here, for example, given this image, the network predict that this image is about a sleep-deprived AI scientist with 85% probability. So that is the first prediction. And then they also have the second prediction, which is, oh, this image is overly tired father with around 10% probability, for example, or 0.1 probability. And so on and so on. So they typically have like some sort of probability distribution instead of a single prediction. Then what we want to do in the training time is we want to match our prediction, this prediction, with the class level or with the ground truth level. So we typically represent this ground truth level or the class level with what is called as a one-hot encoding. So this is what I mean by one-hot encoding, in which that we typically represent the correct label, the correct output as a 1, and then the false or the wrong output as a 0. And then what we want to try to achieve is we want to match these two distribution, and we want to see whether our prediction is correct or wrong. If our prediction is wrong, then we must have some sort of error, right? Then by using this error, we could update the internal parameter of the network by using, for example, a backpropagation algorithm. So my point is, during this training time, we try to like repeat this cycle many times until we think that our network could finally produce a sufficiently accurate prediction. Then after we think that the prediction is accurate enough, in testing time or testing stages, we throw away the class label, the ground truth label, and we use the simplified model to predict any kind of input images. So this is how you train AI agent, typically in general. So what I mentioned, what I describing here is what we call as a supervised learning, because we have the class label, we have a supervision from the prediction, from the class level. But then again, there are many other kind of technique that we could also use, that you could also explore in the community, such as like unsupervised learning, self-supervised learning, or even reinforcement learning, etc. Then in terms of classification, I want to show you this picture as well. So this is kind of a simplified visualization in how the network actually learn when we train a classification model. So for example, when we have a model and we want to classify between a class A and class B, what the network actually learn is they want to separate between the class A and class B by using this decision boundary. So the decision boundary could be just as simply as a straight line here. So as you can see here, this straight line can fully separate between the class B and class E. But sometimes a straight line is not enough to separate between class A and class B, as you can see on this figure on the right. So in this figure, there is no straight line that can fully separate between class A and class B. So in this condition, the network must find like another kind of decision boundary. So it could be in a form of like exponential function, or in this case, this is as simply as like kind of a quadratic function in order to separate between the class A and the class B. So this is a simplified figure because I only draw this in 2 dimension. But typically, when we train an AI model or AI agent, the space of the search space is not only 2D, but it could be 3D or even 4D. So for example, in terms of like video classification, we have 4 dimension. We have the X and we have the pixel value in the X and Y, and also in the Z dimension, which is typically the RGB value, the red, green, blue value. And then we also have the time dimension because it's a video. We have multiple images instead of a single images. So that's why the search space is vast and huge. So we can't truly visualize it like this one. So what we typically do to train a network instead of try to visualize it like this is we use what we call as the objective function. So the objective function is just simply a way to try to optimize our network. So this is kind of to be like our main goal when we train AI model. So for example, we typically can use this one is mean square error. So for example, in this case, we have our prediction here, the yi here, and then the y hat here is our ground truth data. So when we train our model, we can just simply subtract our prediction with the ground truth, and then we square it and average it to get the mean square error. And this error is the one that we use to train our model by using the backpropagation. So this is just one of the example, but in classification, there are many other ways to, for example, to represent our objective function. So you could also use what is it called as cross entropy loss, but I won't go into detail about this loss. And there is also what is it called as a KL divergence. So this is one of the ways to compare between two distribution of function, but I won't go into detail of this. So in the end, in order to train an AI model, you should choose the best objective function that represent your task. By using that, hopefully your model can converge to optimal solution. So that is the general concept of artificial intelligence. Now I'm going to talk about a bit research trend in the smart city context. As I mentioned before, the AI application in a smart city is diverse and vast. It could be applied in logistics, medical, building, transportation, houses, and etc. So this is one of the research that conducted by Alam and Dani in 2019, and it's published in Elsevier Cities. So in this research, they proposed a framework to combine between Internet of Things, big data, and artificial intelligence in the context of smart city. So they think that IoT, big data, and AI, they should be implemented properly in order to realize an impactful solution within the context of smart city. But then they emphasize as well that we should also think beyond technology dimension. We should also think about sustainability and livability dimension. In particular, they mentioned that culture and governance and metabolism should be taken into account when we want to create or design an AI-based smart city solution. So this is also indicate that the optimal solution for a particular city might not necessarily work or could be directly implemented in another city, because those two cities might have different culture, they might have different way of governing uh, the government, etc. So in this case, typically an AI solution is customized for particular city objective. And then this is another example of AI application in the context of air quality monitoring and prediction. As you can see here, the author proposed a smart health application that involves the usage of smart devices and wearable sensors and other kind of embedded devices in order to collect the air quality data uh, from the citizens or even from another devices that they have in the city. So their objective is they should be able to monitor and predict this air quality by using the neural network, and then use this prediction and monitoring in order to improve the health, the overall health of the communities. So as you can see on this figure, they try to use different kind of neural network algorithm in order to predict the air quality condition or the air quality condition based on different data acquisition. So for example, if the data is taken from a bracelet or from a mobile sensor, and then the data is in the format of signal, then they use CNN, DBN, and RBM. So DBN is deep belief network, RBM is a restricted Boltzmann machine. You can learn more about this from their paper. So this is just one of example of AI application in the air quality monitoring and prediction. Another application is in energy sustainability. So these researchers that published a paper in MDPI Energies, they propose a smart grid and smart metering optimization by using AI and big data analytics. So what they want to achieve is we want to improve the efficiency, especially related to electricity consumption, by optimizing non-intrusive load monitoring. So they combine between genetic algorithm and support vector machine in order to predict this non-intrusive load monitoring. So by using this data, they kind of be able to balance between the supply and demand of electricity consumption within a city. And then another application is in the area of communication and resource management. So typically in a city, a massive access to the internet from public devices, from mobile devices and IoT devices, they require flexibility and efficiency in term of management. So what they try to propose here in this paper, I enable massive devices, multiple access for smart city. They propose an innovative and flexible scheduling method. So they try to schedule the resources and the bandwidth that available within the city, such that they could allocate it better for particular purpose. So for example, in this pandemic era, when maybe the health area might require more access to the internet, then they can somehow schedule it and allocate it for that particular sector. So this is just one of some example of research direction that has been conducted by many researchers around the world in the context of smart city, but I'm not going to be able to mention all of them. But after this, I'm going to focus about the AI implementation in the context of Jakarta Smart City. So let's now move to the third part of my talk, which is the AI implementation in Jakarta Smart City. Before I'm going to talk about the AI implementation in Jakarta Smart City, I'm going to introduce to you a bit about Jakarta Smart City framework. So in Jakarta Smart City, we have these 6 layers. So the first layer, which is we call it as a smart city end or smart city goal. So this is the end goal of a smart city, which is to create an innovative city and to improve the happiness of the citizens. And then from these two goals, we want to achieve these two goals by using these three values, which is the quality of life, economic growth, and sustainable environment. And then we use the fourth principle, which is the next layer, in order to realize all of these value, which is the mobile first system and data-driven technology, smart collaboration, and digital experience with AI inside. So what I want to emphasize here is that AI application is implemented within the Jakarta Smart City framework. Although I'm not going to discuss more detail about all of this layer, but my point is AI is something that is common to be implemented in the context of Jakarta Smart City. And then we also has the concept of smart city ecosystem platform. So in this concept, we consider smart city as a data. We also consider smart city as a service, as a platform, as a hub, and then as an ecosystem. So in the context of smart city as a data, so we think that the data is recognized as a significant asset for the deployment of smart city, such that the smart city data can impact multiple services and multiple domains and multiple government application. And then in the context of smart city as a service, smart city, particularly Jakarta Smart City, should provide secure, reliable, and fast integration based on application programming interface that can be consumed by different or other public sector. And then in the third concept, Smart City as a platform, Jakarta has created a digital platform that are ready to be used by many co-creators. So in terms of this platform, Jakarta has what is it called as a Jaki. So Jaki is a super app that combine many different application and platform into a single app. So communities, industry, and startup, they could deploy an app in this super app platform, such that the citizen of Jakarta, they could access government services by using only a single click from this single app. And then as Smart City Hub, Jakarta also integrate various data platform into different services. And in the Smart City as ecosystem, Jakarta Smart City building a new business model that is not only depend on the government financial restriction. So Jakarta Smart City can also take a profit from their services to other organization. So that's a bit introduction of the Jakarta Smart City framework. So related to AI application in Jakarta Smart City, we have huge amount of data, diverse amount of data in order to create like different kind of intelligent application. So we have citizen aspiration data, we have transportation data, tax, flood, subsidy, health, education, waste, and so on. So this is not exhaustive list. So we have many other more, but this is just some example that you could take a look more. So I mentioned before in the previous slide that McKinsey conducted a study that stated that the first layer of smart city application is the technology layer, in which in this layer there are many deployment of IoT or sensor devices throughout the city. So in Jakarta Smart City, we also have IoT devices deployed in different part of application, different part of domain, in different area of the city. So for example, we deploy IoT for garbage truck tracking, and we deploy IoT for smart street light. We also deploy IoT for ambulance tracking, Jakarta bus tracking, to monitor air pollution as well, to monitor the operation of water pump as well, and also by collecting data as well from geotagging application that we have in Jaki super app. So then again, after we collect all of those data from IoT application and also possibly from another government institution, then we typically convert all of those data into what we call it as a analytic dashboard. So this is just example of the analytic dashboard that the Jakarta Smart City has. So this is the example of analytic dashboard for the CRM application. So is it like a customer relationship management application in which that a Jakarta citizen, they could kind of complain any kind of Jakarta city's problem, such as like flooding and then garbage problem and etc. And then they can type the description of the problem and then upload images to the Jaki Super App. And then typically monthly or even weekly or even daily, we kind of visualize all of those reports from the citizen, and by using this analytic dashboard before we then create a further intelligent application. So for example, here, as you can see here, you might see that flooding is one of the most popular complaint that the Jakarta citizen report. So this is just another view of our visualization of the analytic. You could also see as well here the number of report and then the average time to coordinating this report between institution, or even you can also see the average time to complete or finish or solve this problem or solve particular complaint. So another analytic is especially related to this pandemic era, and the new norm era is the development of this website, corona.jakarta.go.id. So this is the official center for information on the development of COVID-19 cases in Jakarta. And the data that is presented here is updated daily. So as you can see here, for example, you can see the number of cases in Jakarta or even in particular region in Jakarta. You could also even see the map. So where is the COVID-19 cases distributed throughout Jakarta? And you can even also see the chronological order of the infection between people in Jakarta, especially in the beginning of the time when the first COVID-19 cases appear in Jakarta. And then this is again the citizen aspiration that I mentioned before. So I just skip this. And then now we go into some AI application that has been deployed in Jakarta Smart City. So this is the example from a social mobility limitation assessment and prediction. So this mobility assessment and prediction is particularly interesting in this COVID-19 pandemic era, because at this time, typically the government enforce large-scale social restriction or even partial lockdown in particular area, such that it completely limit the mobility of the people throughout the city. So as you can see on this graph here, that after the large-scale social restriction implementation or lockdown in Jakarta, then the number of mobility in Jakarta suddenly reduced significantly, particularly if it's related to working or maybe go to public transportation or public station, train station, etc. But then again, surprisingly, the mobility for a recreational activity. So for example, when the people go to mall or go to other recreational places, they increase quite significantly compared to when before pandemic. And then after this kind of visualization and analysis, we typically try to extrapolate the data either by using simply a regression or another time series analysis, and then we can use this kind of prediction and analysis in order to predict the future mobility. And then this is another application in the area of image understanding and video analytics. As you can see here, especially in the new normal era, the face mask detection is quite important, especially in public spaces. As you can see here, by using the CCTV, we can detect which person that used the face mask and which person that did not wear a face mask. And then by using this automatic and comprehensive monitoring, we could follow up with several actions such as We could, for example, separate the people that do not wear a mask from the crowd, or we could also prohibit them to enter public spaces such as a train station, or we could even help them by giving them a face mask for immediate use, or we could also even give them a sanction. So this is kind of example of how AI can drive how government in a city create a policy. And then this is another application of the image understanding and video analytics in terms of the enforcement of a social distancing measure. So as you can see here, by using again a CCTV camera, we could detect people that has implemented a social distancing measure. So if, as you can see here, if it's identified as a green square here, it means that those people has implemented social distancing measure. While if it's identified by the red square here, then this group of people, they violate the social distancing measure. And this kind of application can be used in public areas such as markets, mall, and station. And then this is another example in which that computer vision and image understanding algorithm can be used to help detect the violation of traffic rules. So for example, here, the application detect in which area a car or a motorcycle should move or should be ride by the people. And then they also detect that this area should not be crossed by the motorcycle or car, because this is a pedestrian area. So when there is a motorcycle cross this path or cross this area, we could identify them as a violation of the traffic rules. So we could then even, capture the plate number or something like that, and then we could give them a sanction, for example, in the future. And then another application is in the area of customer relationship management, or CRM, or in Indonesia term is cepat respon masyarakat. So in the CRM application, as I mentioned before, the citizen can upload the images related to the complaint that they made. So for example, they could complain or report about the flooding events, or they could report about a garbage problem, for example. And what we do in the backend in the application is we try to automatically classify or categorize which one is considered as a, for example, a flooding event, which one is categorized as a garbage problem. And as you can see here, this is the example of how our algorithm could accurately detect which one is conditioned as a flood event and which one is conditioned as a garbage event. So this is the heat map here. So the area that the network put attention to in order to predict the images. So as you can see here, the enhanced slim CNN could predict that this area is related to flooding event. So this image should be categorized as a flood. And then this area is categorized as a garbage, and then that's why this image should be categorized as a garbage. And we could also convert this area into a bounding box like this. So what we do is we try to convert this area into edges like this one, and then we convert it into a bounding box such that we could finally compare it with the ground truth data that we created by ourselves, like you see in this figure. And then there are many other kind of features and applications that we deploy in Jakarta Smart City related to image understanding and video analytics. So such as this is for semantic segmentation of the road, or this is for like motion detection from the CCTV as well by using optical flow algorithm. In terms of weather or rainfall prediction, we typically also have like some kind of a simple analysis and algorithm by using, for example, statistical model like SARIMA in order to detect when is the rainfall will be at the highest, at the peak in a particular month. So as you can see in this figure, typically the raining season is only happen in particular month. So we could use a seasonal algorithm like SARIMA in order to help us predict the rainfall condition. And another application of AI that we have as well is called coronal likelihood metric, or what we call as a CLM. So this is an application for pre-screening of COVID-19 condition. So in this kind of application, the citizen can fill the risk assessment that is available in the application. So such as the citizen can fill the demographic condition, and then the history of COVID-19 symptoms, and also the patient history as well. So for example, the travel, when is the last time they possibly contact a COVID-19 person and something like that. But then given all of these input data, we use some kind of probabilistic algorithm such as naive bias in order to classify the risk of this person to be contracted by COVID-19. So for example, we could classify them as low risk, a medium risk, and a high risk, something like that. And then if we classify the person as the high risk, then we recommend the person to do a full COVID-19 test. So for example, they should visit a health institution to do PCR test or even or swab antigen test and something like that. So that is the example application of AI in the context of Jakarta Smart City. Now we move to the last part of my talk, which is about the challenge and the future work that we could do in this context of application. So in order to develop or deploy an AI application, we should also think about not only technological aspect, but also non-technological aspects, such as legal framework. So government and vendors that implement AI for smart city, they have to consider how to navigate with the existing legal and regulatory framework, which govern how to deploy and develop AI system. So for example, in European Union, they've released a white paper entitled AI, European Approach to Excellence and Trust in 2020. Although they have this kind of white paper that can guide organization to deploy AI for smart city, there is still no specific legislation, typically, especially in European Union, that could govern AI. So this is kind of the thing that we should also consider, which is the legal framework on how we could deploy or implement AI for smart city application. Because as of today, there is no also regulation or legislation in Indonesia that can govern this AI implementation and deployment. And then another thing we should take into account is trust and ethical guideline. So we know that the use of AI may raise a number of concerns, including data privacy risks, such as, for example, when we use a facial recognition or biometric system, we might breach the privacy of the user. So when we design an AI system, we should also consider that the system should be lawful, should be ethical, and should be robust, and they should meet a criteria that is deemed to be trustworthy. So such as we have to comply with the privacy of the user, something like that. In European Union, they have the General Data Protection Regulation, or GDPR, while in UK they also have a Data Protection Act. But in Indonesia at the moment, we still kind of formulating this kind of regulation. So at the moment, we still don't have like a kind of a legal framework to protect the privacy of the data. And then the last thing that I would like to mention is about fairness and reliability. So when we train an AI model, we should also consider the diversity of the data. So for example, when we have a facial recognition model, so when we collect the data, it should cover a broad range of different demographics. So for example, in Indonesia, we should also cover people from Java and people from another island, Borneo, Sulawesi, Irian, and so on. So this is to avoid the discrimination of AI system, because there is a case that is quite famous in a social network, that an AI system, they can predict or they can recognize a faces accurately when the face is from white people, but they recognize it lowly or not accurately when the people is from a black people. So that's happened because the data is not diverse enough. So we should also think about this kind of consideration when we deploy or train our model. So another thing is about transparency. So it's also a challenge in developing smart city, because the thing is with AI model, typically they have low level of explainability. So as you can see, if you know about neural network, we typically consider this network as a black box, in which that given an input, the network somehow will generate the output. But we don't exactly understand how the network could produce or predict this output. So we say that the network has a low explainability. So in this kind of condition, it's become a challenge in order to, improve the reliability of the application, especially when we want to deploy it for the citizen. So in this kind of scenario, typically an appropriate level of human control is required, such that the application can be accepted by the citizen or by the users. And then to conclude my presentation today, as I mentioned before, AI in smart city development can play a crucial role in urban planning, development, and management. And particularly, a correctly targeted AI solution, it could improve a multiple aspect of the quality of life in the cities. But then again, when we try to deploy this kind of system, especially in the government context and in the smart city context, we should also consider the non-technical challenges such as a legal framework, trust, ethical guideline, and etc., such that we could implement a proper AI solution for the smart cities. And I think this will end my presentation. Thank you very much for your attention. I will return the time to the moderator.
Okay. Thank you, Dr. Rizky, for your great presentation session. So the next session is question and answer. And please, for the audience, you can raise your hand and ask the question. So please, the audience, you can ask the question. Starts from now. Any questions from audience? Or you can type also in the chat room here. Okay. Maybe the first question. I have one question, Dr. Rizky.
Yes, please, Mr. Hadi.
Okay. Okay, I will ask about the what is the biggest challenge to apply this kind of AI algorithm, as you mentioned about there are three layers between to implement this AI solution for the smart cities, and also you already mentioned in your last session of your presentation about the challenge also, but uh, I'm curious about the most biggest challenge, which part of your experience in your current affiliation or in your current job, especially to implement or to apply this AI algorithm.
Right. Thank you for the question, Mr. Hadi. So that's a quite interesting question. So if I question about the biggest challenge of implementing AI in the context of smart cities, I would say that the biggest challenge would be the non-technical challenge. So the technical challenge, such as like how to deploy the IoT system, and then how to collect the data by using big data algorithm, and then how to build a model, I think that's kind of Yeah, that's kind of the thing that we could typically do for especially for technical people like me. But and then when we try to deploy this system, there is always a non-technical challenge that we face in practice. So like I mentioned before, like the one of the simplest thing is about the legal framework. Of course, like do we have any regulation that can govern about this kind of application? For example, and then we should also answer the question: do we breach the privacy of the people? For example, when we collect the data from the CCTV, for example, because there is no regulation at the moment in Indonesia, right? So when we try to do all of those kind of implementation, then one of the most difficult thing to consider is about the non-technical aspect. And then another thing is about how to kind of what is it? Because typically in the government there are many institutions, right? And then this kind of these different institutions, they have different kind of objective. So one of the most difficult thing is how to kind of like unite their objective for particular task. So when we try to implement one of the solution, then sometimes another institution might not agree with what we're trying to do. So this kind of as I mentioned again, non-technical challenge is one of the most difficult thing to face when we try to deploy or implement our AI system.
Okay, thank you for your answer, Dr. Rizky. So I have two questions from the chat room. First question I will read here. Since the AI model in GSC collected a lot of data in many forms to build predictive model, I would like to ask in the perspective of security, what is the security protocol that GSC used to mitigate any loss in data? Is there any embedded algorithm attached with the prior AI model? Furthermore, this data contain very important information with citizenship and vulnerable to be misused by non-responsible party. Okay, you can ask this first question from the chat group,
Yeah,
Dr.
thank you,
Rizky.
Mr. Hadi. This is a quite interesting question as well. So, what is the security protocol that GSC used to mitigate any loss in the data? So, we typically we have our local network with what is it, like a VPN, something like that. So, which means that the one that has this VPN access are the one that could access the data. So anyone outside the network should not be able to access the data. And of course, we have like username and password, and every people they have different kind of password and username. So typically, like the data should be secured by using this kind of mechanism. But of course, again, for another data like images data, there could be also like a kind of encryption, but that's also. But I'm not an expert in this kind of area, but I just know that there should be another kind of an encryption for this kind of communication. And then is there any embedded algorithm attached with the prior AI model? Fatima, this data contain very important information with the citizen. Right. So what do you mean by the embedded algorithm? So because typically all of the data and all of the data is safe in the local server. So it's not safe with the third party. And so we don't, if you use a third party software, then a third party software will be deployed in the local server. So we typically call this as a on-premise solution. So all of the data, all of the algorithm is deployed in our server. And if there is a third party or vendors that want to help us, for example, in a project to deploy an AI application, we typically have the NDA, non-disclosure agreement. So between these two parties, they should not exchange data beyond these two parties. They should not like share the data to another party beyond this two party that perform this NDA, non-disclosure agreement. So I think that should create some sort of at least a barrier to protect the data that we use in our implementation. Yeah, I hope that answer your question.
Okay, I think that could be answered the question from the first question from chat group. And then the second question is from Hanuraga. Good evening, Dr. Muhammad Rizky Utama Saputra. I think IoT implementation on a big city is very interesting. However, can it can be implemented outside Jakarta? I think it will be great if Indonesia have major IoT ecosystem that can be accessed by everyone. So please, Dr. Rizky, you can answer the question.
Yeah, thank you. Thank you, Mr. Hadi. Thank you for the question, Mr. Hanugra. So yeah, IoT implementation is of course very interesting, especially in development of smart city. If the question is how can it be implemented outside Jakarta, the answer is of course yes. It can be implemented outside Jakarta. But then again, there are non-technical problem to implement this, right? So there should be a funding to be able to implement that. And there should be maybe internal kind of regulation or internal kind of program to implement that. Like for example, maybe in Jogja, they could also track, the Jogja bus, for example. And something like that could also, of course, be implemented in outside Jakarta. But then again, the problem is not, I believe, it's not only technical. The main problem is not technical. The main problem is the non-technical problem. Like for example, whether there is a funding or whether the local government want to implement it, because Indonesia is like it's a big country and each region they have some sort of autonomy. So if they want to implement it, if for example the national government suggests each of the region to implement one thing, so but they will give the right how to implement it for each each region, right? So that's kind of quite difficult to be able to implement it widely in Indonesia, because there is a non-technical challenge that we have to tackle. I think it would be great if Indonesia have a major IoT ecosystem that can be accessed by everyone. Yes, of course, I agree with you. But then again, as I mentioned before, the non-technical challenge, the funding, and then the regulation that could hinder this kind of implementation. I hope that answers your question, Mr. Hanugra.
Okay, thank you, Dr. Rizky. So again, we have another question from the chat group. Cybersecurity is big issue in Indonesia. What is your recommendation as such a great security system? So this complex smart city system is efficient to implement in our country, along with public concern about the data theft recently. Okay, but I think this cybersecurity is not your expertise, but I think you can give some advice, maybe, Dr. Rizky, or recommendation here.
Yeah, thank you for your question, Mr. Irfando here.
Yes.
Yeah, as Mr. Hadi said, cybersecurity is not my main expertise. So my main expertise is in the area of AI, machine learning, and deep learning. But if I would like to say related to cybersecurity problem in Indonesia, I think, as I mentioned before, the technical challenge is easier to tackle, but the non-technical challenge would be the one that is quite difficult. So, for example, in like even if we have quite
I think Dr. Rizky is.
Sorry, my connection lost.
Okay, it's coming.
Yeah,
okay, please
I'll come back.
continue.
Sorry, so I think my connection is not stable. Yeah.
No
So what I said before, right? So what I said before is even if we have like very strong security system, but sometimes the problem is not from the technicality, but the problem comes from the non-technical aspect. Like for example, the people that not careful not carefully use the technology, or the people could be even misuse the technology. So it's not only about the technology, but the people itself. Sometimes it's not ready to implement a good security solution. I think that's my answer for this question. Can you hear me clearly? Yeah, my connection is somehow unstable suddenly.
Okay, yes, it's clear, I think, Dr. Rizky. Oh, okay, I think that could be answered the question from Mr. Irfando. And then, is there any other questions from the audience here? I think that's all from the chat
Maybe Mr.
question.
Hadi.
Okay.
Hello. Can I ask a question
Yes.
to
Hello.
Rizky?
Sure.
Yeah,
Sure.
maybe
Please.
let me introduce myself. My name is Tandi. I'm also for the MC for today. So like from like Mr. Abdul Hadi said that Pak Rizky also have an expertise in AI and also machine learning, and I would like to know like what those AI in like Jakarta smart city is working on. Like for example, does the AI like working on the traffic light to reduce the traffic light congestion or something like that. So I mean like what does AI work on the implementation in Jakarta smart city?
Okay.
Thank you.
Thank you for the question. You can answer, Dr. Rizky, about the implementation. Maybe is it in the traffic light or something?
Yeah. So, sorry if I don't hear your question clearly because of my internet connection unstable. But if I understand your question correctly, the implementation of this kind of traffic management is typically by using the CCTV that is deployed throughout the city, like for example in the road, and then by using the CCTV data, we could analyze, like for example, the mobility pattern or the amount of traffic congestion in particular road. So then we could potentially analyze. So for example, so this particular road is typically has a huge or high congestion level in specific time. So we could then kind of like use this to in order to base future regulation development for this road. So for example, you could limit the number of the road. You know, if you know in Jakarta there is a ganjil genap as well. So that is the regulation about the ganjil genap, the even and the out is based on like kind of this kind of data analysis. So for example, if this road has a like huge amount of motorcycle or a huge amount of car, and then we somehow like enforce the government, the local government can enforce to implement like the ganjil genap or odd and even regulation for particular route. So I think that's one of the application, but we could also kind of typically in this pandemic we also analyze about the mobility comparison between like before pandemic and after pandemic. So you know that in the pandemic era, there is huge decrease of mobility in Jakarta, right? So we could also use this to analyze as well about like what we could do or what we can plan for future, for example, road construction or something like that. Yeah, I hope that answered your question. I couldn't hear your question correctly, so I hope that's
yeah, that's quite like answer my question, and thank you for the answer, Mr. Rizky.
Yeah, thank you for your interesting question as well, Mr. Hartandi.
Okay, so we still have time, but if there is no question, is there any other question from the other participant or the audience?
Yes, if I may.
Yes, please, Mr.
Alex. Yes.
Okay.
Yeah. Yeah. Good morning. I mean, my name is Alexander. I'm from Drone Passengers, named Frogs from Yogyakarta. It was a very interesting presentation that you share with us this morning. My question will be then, I heard that in UK, in the United Kingdom, there is such a, how do you call it, sandboxing using drone passengers in unsegregated airspace, especially for, I think the purpose is only also for smart city projects. Do you have any further information about that? Because I think United Kingdom took a very big step. I mean, by Brexit, and I believe this is one of the advantages for them, because in Europe the area is quite how do you call it, difficult to control or to regulate, basically, from the point of EASA or European Union. So with this that the UK is out from the European Union, they can have disadvantages actually by having their own airspace. What do you call it? Environment. Yes, that's all. Because I think Indonesia have also quite big advantages, as they have a very large airspaces, from Sabang and until Merauke, and we are thinking to have a similar use case for Indonesia, but in what do you call it, segregated airspace, because here I think in UK you will have a mix between aircraft, like airport traffic management and unmanned traffic management, while in Indonesia you will have a segregated airspace that I think is much easier to be applied. Thank you so much, Mr. Rizky, and good luck with your project.
All right, thank you.
Thank you, Mr. Alex.
You can.
Sorry, Mr. Hadi, do you say something? I couldn't hear you. Yeah, Mr. Alex, if I understand your question correctly, so I honestly don't have any information about the usage of drone in United Kingdom. But yeah, what I know about the usage of drone in United Kingdom is that even for like public usage, like for example, just for a photography kind of thing, you should have a license to fly the drone. So yeah, it's different compared to Indonesia. So in Indonesia, you just simply fly the drone like kind of everywhere. But in United Kingdom, even like for me, for example, if I want to fly a drone, I should have a license for that. So that's why it's quite difficult to even to do a research for using a drone in UK at the moment. So this regulation is just enforced like in the past, I think 2 or 3 years. So previously, it's easier for us to do research by using the drone. But at the moment, so even just to fly a drone outside our building, we should have a license and we should have a permission from the government. So typically, what we do, we just fly it inside our lab, and then when we need to fly it outside, then we have to do like some kind of long administration in order to be able to fly it outside. So that's the only thing that I know about this kind of area, the drone area. I'm sorry if this don't answer your question, but
no problem. Thank you so much, Rizky. Thank you so much.
Yeah, no worries. Thank you.
All right. Thank you for your answer, Dr. Rizky. Because of the time is already in the last session, I think we can close our question and answer session. We already has many questions and very interesting discussion here. I hope that all of the audience can get the insights from this presentation session. I think that's all for this keynote session. Thank you once again, Dr. Rizky, for your great presentation. And thank you for all audience for your participations. I will give the time to the Mrs. Aulia as the MC, and thank you for your attention. See you.
Oh,
Okay.
hello everyone. Oh, Aulia, okay.
Okay, so thank you for all the speakers and moderator today. And as agenda is the virtual photo session. We have maybe